Let us do some more examples on the integral test again. So what is the integral test? It says that if the an, which is fn, so I'm denoting an by fn, that is the an, the terms of the nth term of the series, okay, is continuous, non-negative and decreasing for x greater or equals to b, where b is greater or equals to 1, okay. So it could be start from 1 or 2 or 3 like that. That b can start from any number there, okay, greater or equals to 1. Where b is greater or equals to 1, then the summation, the series and the integral starting from the b, okay, they converge and diverge together, okay. So that's the theorem. Now what I want to do is one of the example from your book. Does the series this converge or diverge? Okay, so first of all, solution, let us write down that in the series format. So it is starting from n equals to 2 through infinity. You can write that as natural log of n over n, right? So that's the series. So we want to check if this series converges or diverges, okay? So what I want to do is let f of x is equals to natural log of x over x, okay? Now, instead of checking the convergence or divergence of this series, what I can do is from the integral test, I can find out 2 through infinity f of x, natural log of x over x. You see that? To check the convergence of or divergence of this series, you can check the convergence or divergence of this integral, okay, starting from the same b here. So that's why I'm starting from, it is this summation start from 2, so I'm starting the integral from 2 through infinity natural log of x over x. That's that n basically replaced by x there, right? So dx. Now how do I find out the integral of this? It is basically, you can do the u substitution there, right? How do I do the u substitution? So you can do set u equals to natural log of x. So du will be what? Du will be natural log of x, so 1 over x dx, right? So 1 over x dx. So that will be, and then if you change the limit, when u is 2, then natural log of 2. When u is infinity, the natural log of infinity will be infinity. So the limits will be like that, right? So what I'm going to do here is basically this can be written as, let me write down like this. So natural log of 2 through infinity, right? And then u du, right? 1 over x dx is du, right? Now this can be written as limit r tends to infinity, because this is the improper integral, right? And then what it is, you can write as natural log of 2 and then r and then u du, right? How much is that? That is u squared over 2, right? So that is limit r tends to infinity u squared over 2 and then natural log of 2 through r. If you plug in r, you will get infinity. So basically it is infinity, because when you do that, you will get r squared over 2 minus natural log of 2 squared over 2, right? And when r tends to infinity, that r squared will become infinity. So it diverges. So this integral diverges means the series diverges. So what you can write at the end, what is the final answer for this then? It is the series diverges, right? So final answer is the series n equals to 2 through infinity natural log of n, okay, over n diverges. Why? Because this integral diverges, okay. So that's what we can say from this theorem, integral test theorem. Okay guys, so let us do another example. It says, does the series 1 through 4 1 over 4 plus 2 over 7 plus 3 over 12 plus this diverge or converge? So how do I find out this summation? How do I write this in the summation form? You see that when there is 1 in the top, 4 in the bottom, 2 in the top, 7 in the bottom, third term is 3 over 12, fourth term is 4 over 19. So what do you think? What would be the 5? If there is 5 on the, what would be the fifth term? Fifth term will be 5, because on the top it is first term has 1, second term has 2, third term has 3, fourth term has 4. So fifth term must have 5 in the top. What will be on the bottom? What do you think? So I think this is 28 there. So this is given in the book as well. But what you can see here is you see that when there is 1, there is 4. It is like 1 plus 3, right? When there is 2, there is 7. It is like 2 square is 4 plus 3. This is like 9 plus 3. This is like 16 plus 3 and so on. So if you do that, then the summation will be, the series can be written as like this. Summation n equals to 1 through infinity. You can write n over n square plus 3. That's what you can write. You see that? N over n square plus 3. Because if you plug in n equals to 1, you will get 1 over 4. N equals to 2 will give you 2 over 7. N equals 3 will give you 3 over 9 plus 3, 12, and so on. Okay, now this is, so what you do is let f of x equals to x over x squared plus 3. Okay, so by the way, so I forgot to show on the previous example, I forgot to show that this is continuous. So let me write down that thing here. So this function is continuous. Let me write down here, continuous. Okay, non-negative, and then decreasing. How do I show decreasing? You can find out f prime of x. F prime of x you will get negative for what values? For x is greater or equals to 2. For all x greater or equals to 2, this function fx is continuous, non-negative, and decreasing. You must show that first. I forgot to do that. So let me show how do I show that this is continuous, non-negative, and decreasing. Okay, let me use slightly different color to show that remaining part of the previous. So this is continuous. How do I go so non-negative? Because what is the fx? F of x is natural log of x over x, right? This is non-negative because for x greater or equals to 2, this will be non-negative. Okay, because it is natural log of 2 over 2, natural log of 3 over 3, natural log of 4 over 4, and so on. So this will be non-negative. Okay, all of them are positive. That's what I was saying. Okay, and how do I show the decreasing? Let's find out f prime of x. What is f prime of x? So what is the derivative of fx? That is like u over v format. So the derivative of the numerator, 1 over x times the denominator, x, minus numerator times the derivative of the denominator is x, right? And divide by x squared. So what do you get? You cancel that x and x. You get 1 minus natural log of x divided by x squared. Okay, so this will be less or equals to 0 if x is greater or equals to 2. If x is greater or equals to 2, okay, this value will be less or equals to 0 because this natural log of x will be less than natural log of x will be greater than 1 at that time. Okay, because natural log of e is 1, and for x is, let's say, I think it is greater than. Okay, I think that one is greater than, because for greater than 2 means for x is greater than for x is equals to 3 and then 4 and then 5, like that. So this value will be basically greater, less or equals to 0. Okay, so this is what you get. All right, so we can see that this function fx is continuous, non-negative, and then decreasing for x greater than 2. Okay, now what we did after that is, so to check the convergence or divergence of this series, you can basically check the convergence or divergence of this integral here. Okay, whatever you put, if you put 3 or 2, whatever you do, basically it satisfy that. Okay, basically you can do, since x is greater than 2, you can write x is greater or equals to 3 here, and then find out natural log of 3 through infinity and natural log of 3. You can do like that. Okay, natural log of 3 and then 3 through infinity, natural log of 3. So either way you will get infinity whether you put 2 or 3. It doesn't make that much difference there. Okay, so on this example we found the summation, the series format there, right? N over n squared plus 3. Now I'm taking fx equals to x over x squared plus 3. So this function fx is what? Fx is continuous, non-negative, okay, and then what, this is also continuous, non-negative, and let us find out what is f prime of x. 1 times x squared plus 3 minus, so x times 2x divided by, I'm using u over v format, okay, this quotient rule, x squared plus 3 squared. So what do you get? You get x squared plus 3 minus 2x squared. So 3 minus x squared divided by x squared plus 3 squared. So for what values of x, this is decreasing. So for x greater or equals to 2, right? So this is less or equals to 0 for x greater or equals to 2. You see that? This is less or equals to 0 for x is greater or equals to 2. Okay, guys? So what you can say is, then this series, and then the integral, okay, you can write n equals to 2 to infinity there, and then just one more term there. So it doesn't change, it doesn't make any change there, okay? Hence, so that's what we got. Now what I can do is, since this is decreasing for greater or equals to 2, I want to take 2 through infinity here, okay? Let's take 2 through infinity, x over x squared plus 3, okay, dx. Now I can do 1/2 and then integral 2 through infinity 2x over x squared plus 3 dx. I hope you understand this, because what I'm trying to do here is I'm trying to get the derivative of the denominator in the numerator so that the integral will be log, okay? So let us write down 1/2 and then limit r tends to infinity, okay, and then do this will be natural log of x squared plus 3, but the limit r 2 through r, okay. When you plug in r, you will get basically infinity, so it diverges. So 2 through infinity, when the limit is 2 through infinity, is diverse, meaning the integral is infinite. Meaning if you write 1 through infinity, it will be infinite because of the comparison test, right? Since this 2 through infinity diverges, then writing from 1 through infinity, it has more term than 2 through infinity, right? More area than 2 through infinity, so it will diverge as well, okay? So you can think of the comparison test there. So what I'm going to do here, I'm going to write is, hence, so the integral 1 through infinity x over x squared plus 3 dx diverges, because 2 through infinity diverges. Since 2 through infinity diverges, then 1 through infinity also diverges, because that has more term, right? Since this integral diverges, hence this summation diverges. So the series diverges, hence the series diverges, okay? Series diverges. So you can say like that, okay, guys? Sometimes you don't get exactly the same integral as here, then you can relate like that, okay? All right, so let us do some more example. So the next example I want to do is example number 13 from your book, okay? So let us do that example number 13. So does the series summation n equals to 1 through infinity, and it says arctan tangent inverse n divided by, you have n squared plus 1, diverge? That's what the question is asking, okay? Does this diverge? So what I'm going to do here is, let me use different color for that. So let's say let f of x is what? F of x is tangent inverse x over x squared plus 1. So this function is continuous, okay? So this function is continuous. This function is so this function is basically continuous, non-negative, and what is f prime of x? If you find out f prime of x, you will get basically 1 minus 2x tangent inverse x divided by x squared plus 1 squared, and this is less or equals to 0 for x is greater or equals to 1. That's what you get, okay? Hence, So what we do, instead of finding this integral, what I'm going to do is instead of finding the sum of this series, I'm checking the integral 1 through infinity tangent inverse x over n squared plus 1 dx. Sorry, x squared plus 1 dx. Okay. Now, so what I'm going to do is I'm trying to find out the integral of that. Okay. So how do I find the integral? So I need to do the u substitution, right? So let us do the u substitution there. So set u equals to tangent inverse x. Then what is du? Du will be 1 over 1 plus x squared dx. Also the limit will be tangent inverse 1 is pi over 4, right? That will be pi over 4. And then another one will be tangent inverse so you don't have to do that. Okay, let us not worry about changing the limit. We'll come back later. Okay, so this integral will become, tangent inverse that tangent inverse x is u and then du, right? That's what you will get, right? So this is u, this is du, so that will be u squared over 2, right? So what do you get? U squared over 2 will become tangent inverse x squared over 2. You see that? Tangent inverse x squared over 2. Now you can write that limit, that integral as basic. I mean, you can plug in those, change the limit and do that. Or because if you don't know what is tangent inverse infinity, that is pi over 2. Tangent inverse 1 is pi over 4, right? So if you don't know that, then it will be the you will have to do this way. Okay, you can change the limit or do this way, not a problem. Now what do you get then? So therefore 1 through infinity tangent inverse x over x squared plus 1 can be written as what? Limit r tends to infinity, right? And then tangent inverse x squared over 2. What are the limit? Limits are 1 through infinity again, right? So what do you get? Let's plug in. Let me write down 1/2. Plug in infinity. What do you get? You will get tangent inverse infinity. That is pi over 2 square. That is pi squared over 4, right? And then minus, I pull that 1/2 out. And then plug in 1 here. What do you get? So tangent inverse 1 is pi over 4. So pi squared over 16. That's what you get. Okay, guys? So if you simplify that, you will get 3 pi squared over 32. So this integral converges, right? Converges. This integral converges now. This integral converges means the series converges. Hence the series converges. Okay, so let me write down that. Hence the series converges. So let me write the final answer here. Hence the given series converges. Hence the given series converges. Okay, so this is how we check the convergence or divergence of a series, by showing the nth term of the series by taking that as a function fx, and then so that it is continuous, it is non-negative and then decreasing, and then find the integral of that function fx. If the integral converges, it converges. If the integral diverges, the series diverges. Sometimes though, the when you find out the derivative, it is less than 0 after certain terms, okay, or after certain values of x. At that time you find out the integral of that after that term, and show that the integral converges or diverges, and then add that one more term. And then, because if the integral converges, adding one finite term does not change converge. If the integral diverges, then adding one more finite term does not change the divergence. Okay, so it still holds after you add one more term. Okay, all right. So in the next video, I will discuss some more examples of the integral test. Okay, guys. All right. Thank you.